Hi everyone. Today we're going to look at adding and subtracting with radicals. But before we do that, we're going to look at some situation that has to apply in order for you to even be looking to add or subtract, and that is that they have to be like terms. It's very similar to when we work with variables. Multiplying works great, which is what we've been doing. You can multiply. It doesn't matter that these are different. We multiply the coefficients, and then we multiply the x to the fifth and the x to the third, and we get x to the eighth. Radicals were the same deal. Multiply your coefficients, and you multiply the radicals. That worked great. Adding and subtracting is like variables as well. In order to add, these have to be like terms. You have to have an x, and this has to be an x. This can't be an x and a y. Can't be an x and an x squared. These have to be alike. If they are, then you can add them, and you really just add your coefficients, and you leave the variable part the same. Radicals are identical. Add the coefficients, leave the radical part the same. Simple as that. Let's try it. In this example, in this first example, you can see that this has a negative. We assume it's a 1 right here. The coefficient is -1. The coefficient on this one is 3. If I add the coefficients, I end up with a 2. And remember that the radical part stays the same. On this next example, you have 2 root 2 minus 3 root 2. You work with the coefficients, so 2 minus a 3 would get you a -1, and you leave the radical part the same. We probably wouldn't write the 1, we'd probably write that -square root of 2 and call it good. Alright, pause the video for a minute. You try this next one. Alright, hopefully you got a -6 square root of 5. Super easy, right? As soon as you think something's easy, we got to turn around and make it harder. Because the reality is, these radicals oftentimes are not already like terms. Like, look at these examples. These aren't like terms. I have a square root of 12 with a square root of 27. I can't add those together. Can't do anything with that. Or can I? Because the square root of 12 actually can reduce, because there's a perfect square that goes in that. And 27 could also reduce. Let's look at what happens if we can reduce those and then look at them. The square root of 12 would reduce. The perfect square that goes into that is a square root of 4 times the square root of 3, which simplifies to 2 square root of 3. Plus, now let's look at this 27. What's the perfect square that goes into 27? Well, that'd be a 9 times the square root of 3. And that reduces to 3 square root of 3. Oh wait, maybe these are like terms then. They both have a square root of 3 now. You'll find that you need to reduce your radicals sometimes in order to see that two radicals are actually like terms. Now I can add these together. I'll add the coefficients and leave the radical the same. 5 square root of 3. Let's try this next one. Does the square root of 12 reduce? Well, yeah, we just reduced that one. Let's practice that again. Breaks down to a square root of 4 and a square root of 3, which is a 2 square root of 3. Plus, now does this one reduce? Well, it does not. So you won't be lucky enough to always reduce it. I'm just going to leave it a square root of 3. But if you look at it, this is like a 1 square root of 3. These are like terms because they both have the square root of 3. Add the coefficients together. That would get you a 3. Leave the radical alone. All right, so plan to have to do some simplifying before you're able to add them together. Why don't you try this next one on your own and see if you can make them like terms that are going to be able to be combined. pause the video. Holy cow, what just happened there? Look at that one. The square root of 8 breaks down to a root 4 and root 2. The root 4 gets you your 2. But it was negative all the way. I have a negative 2 root 2 plus a positive 2 root 2. Those are going to cancel each other out. If you can manage to get them to be identical, then they cancel and you just get a 0 out of it. We're going to look at a few more here, some bigger numbers, see what we can do with these. This first example is a negative square root of 54 minus 2 square root of 24. By now I'm hoping that you know those perfect squares well and can reduce and simplify these radicals. What goes into 54? That would be a perfect square. 9 goes into 54 6 times. So I'm going to write that square root of 9, square root of 6. It becomes negative 3 root 6. Now we look at the second one. The 2 stays out in front. We're going to break this square root of 24 down. What's the perfect square that goes into that? 4 times 6. That's going to become 2. The square root of 4 comes out nice as 2. Square root of 6. Let's go one more step here where we actually multiply the 2's together. And at this stage now we have our common radicals. They're both square root of 6. So you look at your coefficients. Negative 3 minus 4 would get you a negative 7. Leave the radical alone. Let's try another one. Over here on the right, oh, there's that 12 again. That breaks down to a square root of 4 and a square root of 3. You do start getting pretty familiar with some of the ones that pop up a lot. We've done a 27. That's a square root of 9 and a square root of 3. This term becomes negative 3. The square root of 4 comes out nice. That's why we used it. Here I have 3 square root of 3. Multiply the negative 3 and the 2 together. And once you've cleaned it all up, now you can see that you have these common radicals here. So that makes it possible so that we can combine these together. Negative 6 minus 3. Final answer. These are. Let's practice a little bit more with some bigger numbers, see how this plays out. On this first example, I have a negative square root of 54. I'm going to try to reduce that. The negative just sits out in front here. What's the perfect square that goes into 54? It's a little bit of a different one. That'd be a 9 and a 6. 9 times 6 is 54. Minus 2. Break down the square root of 24. You got to think of the perfect square that goes in there. You should use 4 times 6. Now let's reduce these. This is a negative 3 square root of 6 minus 2 times 2. Remember the square root of 4 comes out nice. That's why we chose it. Which now becomes negative 3 square root of 6 minus 4 square root of 6. These are now like terms because they both have the square root of 6. So let's work on their coefficients. I have a negative 3 minus 4. That gets me negative 7 square root of 6. There's my final answer. Example 2 here. I've got this coefficient on the front that just always just hangs out there. Continue on down. Let's break down the square root of 45. The perfect square that goes in there is 9 times 5 minus 2 square root. All right, 80. What goes into 80? 84 would go into 80. But we've learned also that it's not always the first one that comes to mind. Sometimes something bigger goes into it, and 16 actually will go into 80 5 times. So make sure you're always picking the largest perfect square. Otherwise, you're going to find that these would not have gotten me the common radical. You'll see here in a minute. This is going to be 2 times 4 square root of 5. Now we can multiply these numbers that we've got. I end up with a 12 square root of 5 minus 8 square root of 5. If I had chosen a smaller, like the 4 right here instead of the 16, this would not have ended up square root of 5. It would have been some number that would have continued to reduce, and it creates more work for you. Always look for the biggest perfect square. These are now like terms, so I get to combine them. 12 minus 8 is 4 square root of 5. Pause the video. You tried this one. It has some bigger numbers in it. See if you can get this one to work. Hopefully you got a 3 square root of 7. If you didn't, go back and look and see where your work varies from mine. And again, if you're not showing nice steps on this, it's going to be hard to backtrack. Always make sure you're showing nice work that can be tracked. I can help you better that way every time if you have something there for me to check. All right, that's all I've got for you. Go ahead and give the homework a shot.